In this video, we'll be basically taking a look at what are called DML, or database modification language statements in T-SQL, and more specifically in Module 4, we'll be examining the select statement and how it helps us retrieve data from the database. We'll also be examining statements that pertain to database modification. We'll specifically be looking at the insert, update, and delete statements. And finally, we'll be examining the functionings of aggregate functions with the select statement. So let's get started. To provide a synopsis of the common DML statements discussed in this first video of the module, we're going to be taking a closer look at such statements. So the main ones discussed are select, insert, update, delete, and bulk insert, with select being considered the most basic of all the DML statements, because essentially it's a function that's used to retrieve specific rows and columns from a database table. And the way of writing the script for that function is using the word select, of course, and then the asterisk symbol followed by from and then the name of the database table. So the select statement necessitates the actual name of this table, and the asterisk is used because it's telling T-SQL, the program, to, with the asterisk, it's telling it to retrieve data from all of the columns, or alternatively, retrieval may be performed on specific column names if they're given instead of the asterisk. But this asterisk allows for the function to search and retrieve for all available columns. So this can be a little bit time consuming. So instead of using asterisk, you can also include a where clause in the select statement to narrow down the search function and retrieval function. So an example of such select statement would be including the names of specific columns as mentioned instead of the asterisk. In this case, a business entity ID, a job title, and a gender. It's specifying the name of the database table. And then a where clause is provided to narrow down this retrieval to columns in which the rows for the entries, for business entity ID, are less than or equal to 50. So that's what it's going to do. It's going to return a result that looks like this. It'll have the 3 columns specified, and then it'll continue to retrieve the data up to and including row number 50, because this where clause was included in the script. So that's the basic methodology with the select function. There are cases in which multiple where clauses can be used to even further refine the retrieval function. And some examples are given, such that it can be for a job title, and the and operation is used, of course, because it has to be both coexisting job title and gender. And it can even have a second and with a higher date. particular hire date. And this is used, of course, this would be a common use case, including multiple where clauses would be commonly used for very, very large databases. There are many, many entries. So that you can further narrow down the desired results in the function. To give other examples with now you can even use in some cases you can even use the or operation to broaden, right, the data retrieval in the function. So it's really up to the person who's writing this retrieval script to decide how to narrow down the data in the retrieval. What kind of and clauses and what kind of or clauses may be used. There's even another clause aside from and or. There's something called the between clause, or actually similar to the select. I mean, the select function, you can actually use what's called between. So within the where clause, what I mean is within a select function, inside of the where clause, between may be used to retrieve more specific results, essentially, in the function. In this case, between 75 and 100 vacation hours per employee. Some other examples are given here. So there are a lot of options here for how to narrow down and return and retrieve specific results. And there is even a not clause. And really the not, just like the as the name would imply, it would negate any results containing particular field or data such as gender being equal to M in an employee database retrieval. So many options for narrowing down the results. Furthermore, we can use another method at our disposal for retrieving results would be to use a union clause, which is essentially functions the same as a union of an event, the union symbol in a Venn diagram, and that will elicit a cross section of data essentially between two fields. So you can actually combine results between two fields from multiple select statements, as in multiple databases, essentially. So the union provides results for the intersection of fields between multiple databases, which is kind of interesting. Or it could even be within the same database, actually. Some other clauses are given. They're not as commonly used, except, as the name would imply, it's similar to a not clause, except you can negate multiple fields, and intersect, similar to union. Then you have the join clause, which is what that one is actually used to combine or retrieve data from multiple tables, independent tables. So that's what the join clause would be used. There are even further subtypes of the join clauses. And finally, for those interested in retrieving essentially summarized data, summarized fields, if you will, you can use what's called an aggregate function. And it's the naming of these functions are very similar to even something you would find in a Microsoft Excel program, average, min, max for particular field. You can, as T-SQL is able to perform functions, common statistical functions essentially, and retrieve them. So there are many options. So in summary, there are many options for delineating and retrieving particular results from a function, from a database actually, using different DML statements, the first and most basic of which is the select function. So we will move forward to the next part with a actual practical demonstration of the select function on Microsoft Server Studio Management. In the select statement demonstration video in this module, the database that's being utilized is called AdventureWorks 2012. This is a database that's freely available for download online as a .bac file, which can then be restored to the SQL Server and then subsequently used in Microsoft Server Management Studio. So that's what we'll be doing right now. We're going to actually perform a search for this AdventureWorks database. And then we're going to follow the instructions here on Microsoft's website. Essentially, all we have to do is download the OLTP data version of the file ending in 2012. While that's being downloaded, we'll be looking at the next instructions. So we're going to, once the file is finished downloading, we're going to move this to our Microsoft SQL Server file in our C drive. And then we're going to perform a right click on the database and then select Restore Databases. And then from there, we'll add the .bac file so that the SQL Server knows where it's located, essentially. And then once that's confirmed, we'll go through some of the prompts here for selecting our backup devices and the restore location of the file. Once that's completed, then we can finally restore a database and then essentially utilize it in Microsoft Server Management Studio. It's done downloading. So what we will do now is I'm gonna move the file to the C drive location. So in this folder, we'll make a new folder called backup. We'll paste. We'll paste the .bac here. Next, we will open SSMS. We're already connected to the SQL server here. And then under databases, we'll right click and select restore databases. And then we'll select from the device file, we'll add. So this is actually housed under MySQL 16. So actually we'll move the file to that same location. Go into Program Files, Microsoft SQL Server, and then the 16 SQL Jasmine, and then we'll actually just move that here. So we'll go back and add. So there is the .bac file. And actually we'll move that to a backup so it's a little bit more. Move this to backup here. So one more time. There it is. Okay. Okay. And okay. So there it is. AdventureWorks 2012. So to look at our one of the many tables featured in this database, open something. You can see that now within the same AdventureWorks 2012 database, we're going to perform a practical demonstration by using the select statement to create a specific table within this database. We're going to create a table using a query script of human resources dot employee. So we're just going to right click on the database here and then select new query. And we're going to use the same query script with the select statement here. To use AdventureWorks 2012. Go. Next. This is note or comment. Columns and rows. Select all or select asterisk, which selects all the rows and columns of from database human resources dot employee. table. We're going to select all of this script, and then we're going to select execute. And there we have it. We have the table of the human resources dot employee using the select statement. So you can see all of the tables, all the columns rather, columns and the rows of that table appearing. You see the query was executed successfully. So you can see all of the information and data on the table that is contained in the table. Next, we'll perform a second select statement, this time including the where clause to specify a specific number of rows within this table. So this table contains 290 rows, and we want to display a table that only contains 50 rows. So we'll be using the where clause to accomplish that. So in the example provided in the video, we're still selecting the same columns from the table, from the same human resources.employee table, and then we'll use the where clause to specify the job title and the gender and the hire date parameters to essentially provide a more specified result of data in rows. So I'll use this script here that's given in the video. I'll go ahead and paste it here. This will include the business entity ID row number being less than or greater than 50. So basically, we're expecting to see a table that will contain rows 1 through 50, according to this where clause. So we'll select this, execute, and there we have it. If we scroll down, you can see we can first see that the query is completed successfully. You can see the table, and the last row on this table is 50, just as we had specified according to the where clause. Now, we can also use the where clause in combination with the and parameter. So actually what we did previously was this script. Next, we'll perform this script, still using the where clause, but with the and operator this time. So this is the same thing that's just written in the notepad. We'll just paste that here. So we can always further refine the data by using the and operator. This time we're going to refine it down to the job title, the gender, and a particular hire date range, greater than or equal to January 1st, 2000. So basically, we're expected to be return results containing female design engineers that were hired on or after January 1st, 2000. So we'll go ahead and select that, and then we'll hit execute. So according to this select statement that was formed, there are only 2 results of employees that fit the aforementioned criteria according to the where clause with the use of the and operators. Now we can also perform a similar select statement if we wanted to kind of broaden that search just a bit. We can include instead of using the and operator, we can include the or operator. So it's very similar to the previous script, except that now we're going to look at results in which the vacation hours of the employee is greater than 80, or, so including also any employee with a business entity ID of less than or equal to 50. So copy the first 2 lines of this script and go. Instead, in the where line, we'll change this parameter. We'll add this parameter rather. Where vacation. You can see that vacation hours is already populated in the queue for this parameter because we already have that included in our view, table view. Basically, it's already, SSMS already knows about this vacation hours parameter. Column. So that's going to be greater than AT or the business entity ID. So you can actually just double click there. Is less than or equal to, it was 50. So we'll select this and hit execute, and there we have it. So each time we have 102 results. Now this one's a little bit broader because this is, the job title is not, it's including all job titles, and it's including all genders, and it's including parameter that perhaps many employees have more than 80 vacation hours, it seems. That's why we have significantly more results elicited here than the previous query. And another reason why there are significantly more results is because we're using the OR operator. So these two parameters don't need to coexist, if you will, within the same employee. One employee can have, for example, more than 80 vacation hours, but still have a business entity ID of less than 50, and vice versa. So that's why when you want to broaden a query, a search query, you can use the OR operator to accomplish that instead of the AND operator, which kind of limits your results to rows that contain all of the above parameters in this example. The next search query we'll be performing will essentially include the between clause instead of the where clause, or rather the where clause, but it includes the between operation, the combination of between and operation more specifically. So this is just another method of further refining and enhancing the results that are elicited from the search, the query search. So we'll be essentially including the first 2 lines from the script added with where vacation hours are between 75 and 100. So all we have to do here is just copy this, and then we're going to change the vacation hours parameter to be between 75 and 100. So we'll include, this will elicit results of employees with vacation hours as little as 75 and as many as 1. So highlight this, just double check it's business entity ID, job title, and vacation hours. So we'll change this field, this column to vacation hours. Okay. Highlight, execute. Now we have the results. We notice that the vacation hour column, of course, is not ordered in any particular manner. The way that this table is ordered is according to the business entity ID, starting from the lowest of 1 to the highest of 233. So in order to control for a particular order of the vacation hours column, all we have to do is copy this script, paste it, and then we're going to use the order by Okay, vacation hours. And the default is in ascending order from lowest to highest. So we'll just have to write that order by vacation hours. And that's about it. So then we just have to highlight this and press execute. Now we see that the first row elicited is has vacation hours of 75. The last one has vacation hours of 99. So we can kind of deduce that basically there is no single employee that has exactly 100 vacation hours. The highest within the between and clause is 99, according to the table. If I wanted to reverse the order of the vacation hours from from ascending to descending, all we have to do is basically, meaning the first result would be the highest number of vacation hours in within the clause 99, and then the last result would be the lowest of 75. All we have to do here is actually include this DESC to reverse the order to descending order, because the default is, of course, as I had just said, ascending. So when we do that, we can see, just as I had explained, the highest number of vacation hours, 99, is the first row, the last row being 75. The next statement we'll execute is using the not clause. So all we have to do here is we're going to just add within our where clause, with the not operation rather, this will produce, performing this execution of the script will result in employee rows that are any employee row that's not male, or M, gender. So all we have to do that is basically use the first 3 lines with our where clause being changed to gender not equal to, just as the example shows, where not gender. So this will return quite a number of results because it's basically any employee that's not male, but that's it. So highlight, execute, so we can see we have 84 results. Next, we'll perform a select query with the union clause this time. Essentially, the union clause combines data from 2 different tables that share the same columns. And in this case, we're going to be looking for any employee with the job title of design engineer combined with the table that contains employees that were hired throughout the year of 2005. So this script can be written here, and then it can be copied and pasted. So what's unique about the union clause is that it requires that the 2 different tables share common columns, which is not always the case with differing tables, but in this case, this works with the columns of business entity ID, job title, and hire date. They have to have the same columns shared. So when we select and execute, we have 3 results. So this also can be accomplished using the union clause, the where and then the or operation, but union may also be used. Next, if we wanted to elicit results that appear in one particular query but not the other, we would be using the except statement. And from there, it'll essentially limit results that appear from the left query, but not the right. So I will grab that from here and then include it here. So we'll select that, execute. And here we have 266 rows that are affected. So essentially what's happening is the data is being pulled from the production product table with the exclusion of results that appear also in the production work order table. So in order to combine the results from both tables, all we have to do is change one word except to intersect. So this will return values included in both queries or both tables in the database. So all we have to do here is copy this script, paste it, and then change this word from except to intersect. So we'll see the change in the results. In the first one, there are 266 rows affected. And then in the second one with the intersect statement, there are now 238 rows that are produced. And we're going to end the demo with a sample aggregate function of one of the tables. The example that's provided, it's basically performing a count of all of the sales orders according to their ID, and the unit price of each particular product that was sold is going to be calculated according to the boundaries of a minimum and a maximum order quantity, essentially. From this, all of this data is aggregated from one single table. It's shown. So this will elicit one distinct result according to first the table, and then more specifically the average unit price, the minimum order quantities, and then the maximum line totals, essentially. So we will copy this and paste this script here. So we're going to highlight that and press execute. And instead of county, it will be count. Typo. So we'll execute. And there we have the average unit price calculated right here, according to, again, the boundaries of a minimum order quantity and the maximum line total. And these are according to columns, again, within this sales order detail table. And that concludes all the demonstrations using the select function and the aggregate function capabilities of SSMS. So we will move forward. To the summary. So in this video, we focused on practical demonstrations using the select statement, which is a type of DML or data manipulation language, to elicit results from one or more tables that are within a particular database. And we used the select statement in conjunction with different types of where clauses to further refine the results that appear in the table, depending on factors such as order, using order by, data that appears in multiple tables with the union clause, this excluding data, as in the case with the except clause, that appears in different queries with the intersect, and then the join, which allows you to combine data from multiple tables. And in the next module, we'll further be looking into the insert, update, and delete functions in SSMS.